already yesterday I have explained in detail how I write the add instruction by different ways. Okay, the same thing is here. ANL for ANDing operation, ORL for ORing operation, then XRL for XORing operation, and some of the instructions which are used for clearing the content of any register or any accumulator or B register. So CLR instruction is there. For complementing the content, CPL instruction is there, and some of the right shift and left shift operators are available. So they for that operation, these are the instruction. RL stands for left shift, RR stands for right shift, rotate right or rotate left. So these are the two instructions. And RLC and RRC, again the same operators, that is the right shift left through carry. C stands for the carry, and right shift through the carry. So these are the four instructions we can say for the two operations, that is the left shift and right shift. So whether you want to perform the right shift and left shift with carry or without carry, depending upon these four instructions are there. And last instruction is swap instruction. Swap, in the swap instruction, what happens is the nibble, that is the nibble is the combination of 4 bits. So if I take a 1 byte, 8 bits are there. So in that, how many nibbles are there? 2 nibbles are there. So 0 to 3 and 4 to 7. So likewise, the nibbles are swapped, the lower nibble and higher nibble. So I will tell you the explanation or the example related to each and every instruction. So these are the instructions comes under the logical operator. So we will see now the examples. Okay. Now see what happens exactly in ANDing operation. Suppose first is the content. So what is the first number? Yes? Anyone? In ANL, that is the
0F.
ANDing operator. 0F. Okay. What is the second number? Any other student? What is the second number? Yes? What is the second number?
5C.
1010? Pi or A? 1010 is A or 1010 is phi?
AC.
AC. Okay. So these are the two operators, and what I have performed is the ANDing operation. So all of you know the truth table. So when both the inputs are 1, so 1, 1, the output is 1. Now see, for remaining all the combinations, if one of the input or one of the operand is 0, 0, 1 comes the 0. So according to that, in this way, you should able to perform the ANDing operation by using the ANL instruction. This is a simple instruction used to perform the ANDing of 2 bits and operator. Okay, same is the logic for ORL and XRL. So what you should know is, you should know the truth table for same. Now for ORing operation, for 0 0 output is 0. For remaining all the combination, the output is 1. So according to that, see what is my first number in ORL operation, ORing operation? 0 F, again the same. And for the second operator, again A and C. So according to that, what is the answer for ORL? So what is the truth table? According to that, I have performed the ORing operation on these two operand, and earlier ANDing operation on these two operand. So just note down these two examples. All of you note down these two examples. Yes, completed. Hello? Completed or not?
मॅम प्रेझेंटेशनची स्लाइड दिसत नाहीये.
प्रेझेंटेशनची स्लाइड का नाही दिसत आहे?
ऍक्च्युली टॅब चेंज केला होता म्हणून आता दिसतंय.
ठीक आहे, नंबर्स तर 0F आहे आणि AC आहे. दोन्ही नंबर्स दोन्ही अँड आणि ऑर ऑपरेशनला सेम आहेत. तर तुम्हाला ते नंबर रिप्रेझेंट करून 0A 0F आणि AC मी हे चेक करते की कोण कोण आहे जॉईन झालंय आणि त्याच्यासाठी मी टॅब हे केलं होतं. First operand is 0F and second operand is AC and you have to perform the ANDing operation and ORing operation. Diksha Patil is there?
Yes, ma'am.
Hello Diksha.
Yes,
Show
ma'am.
me your notebook.
Yes,
Show
ma'am.
me your notebook. You can just show me notebook. Means whatever the operands you have taken and the answer. Okay, AF and AC. Okay, good. Okay. So understood the concept of ANDing and ORing. Same is the logic for XORing also. Okay. Now we will see the XORing operation. Now see, again I have taken the same operand. You can take the different operands. So the books in the book they have given the number of example, but this is very simple thing already you know. Just I have taken one example for the understanding purpose. Okay. So again the XORing, the truth table. How you remember the truth table of XOR gate? How you remember? There is a logic to remember the XOR truth table. No need to mug up the table. What is the logic for the same? Hello? What is the logic to remember the truth table of XOR gate?
For same bit,
For same input,
output is
output is
0.
For same input, one
zero.
at a time. Yes. When both the input bits are same, that is A and B, always output is 0. And if one of the input is different, output is 1. Okay, means according to that you can just make your truth table for XOR gate and you can apply the logic. So see, I have taken the same example and the answer is in front of you. So these are the three basic logical operators: A and L for ANDing, ORL for ORing, and XRL for XORing. Okay. Now already I told ki apart from these two instructions are there which are called as CPL. So what is CPL? I told is it is used to complement the bit. Okay, and all of you know the meaning of complement, negation. If the bit is 0, it after complement it becomes 1. If bit is 1, after complement it becomes 0. So likewise, so for that purpose I have taken again the second number, that is AC for complementation, and the answer is in after the number, that is 1 is 0, and if it is 0 it becomes 1. It is just a simple example of complement the bit, complement the number. If you want any operation related to that, we should use the instruction called as CPL, used to complement the bits in the any number in register content, any register content. Okay, so after that the rotate instructions, or the right shift or left shift we can say. So first of all, before studying this instruction, can you tell me why to study this right shift and left shift operators? What is the use of these two operators? Only the shifting data, but what happens when you shift the data? Any one student? Hello? Why to study this rotate operator, or why to study the shift, that is right shift and left shift?
Ma'am, to interchange the bits.
To change the bits. So what you are achieving by changing the bit? Why to change the bit? What you want by changing the bit? There should be some logic na ki yes, I want this operation, I want this logic, so that I can go for right shift and I go for left shift. What happens when you do the right shift or left shift to any number? Do you know that concept?
Hello, ma'am.
Ha bolo.
Yeah, ma'am. When we use the left shift operator, then the number is multiplied by 2 raised to n.
Hmm.
And when we do the right shift, then the number is then the complete number is divided by 2 raised to n.
Exactly. The logic behind the shift operator is this. And for that purpose, one should study the shift operators, that is the right shift and left shift. Okay. Now see what happens is there are two basic operations, that is the left shift and right shift. But whether you are shifting through carry or whether you are shifting without carry. Through carry means by considering the previous carry bit, and without considering the previous carry bit, according to that the four instructions comes under this category. They are called as RL, RR. So no C operation, no C bit is available, so this is without carry. And RRC and RLC, that is with carry. Now see, on the PPT you could observe the example as well as the way of shifting. So for RL, that is for left shift operator, it starts from rightmost bit to leftmost bit. Okay, so where it starts from the rightmost bit and towards the leftmost bit, so this is the left shifting. So what I have taken is, I have taken one operand in accumulator, so that operand is F0, so you have to do it manually, so on your notebook. And after shifting the content, so it is actually RR, it is RL. So what happens exactly, you just concentrate on the first instruction, move a comma hash 0 cross F0H. So F0 is the number. So when you just rotate that number towards left, what is your answer? Just cross check that answer, or whether the PPT answer is wrong. Just cross check the answer, and how you are going to change, how you are going to rotate that number. So this diagram explains the logic for the same. Yes, whether it is correct? See the arrow position for upward and downward also. And in the same thing is for the right shift operator. You can check both the answers. So when I start with this 0, so 0 is shifted towards left side, so rightmost bit is empty and the last bit is accumulated with the empty bit. So in this way you had to perform this operation. So this is the two basic operations, that is the left shift operator and right shift operator, or rotate left or rotate right. So the two examples are there. So if you understand this properly, so you can just differentiate between RL and RLC. So we will see RLC and RRC. So see, what is the change in RLC and RRC? So first of all, just check what happens exactly. RRC. So what I have taken here is, I have taken one number in accumulator. So now you should able to interpret the instruction meaning, what is telling, what that instruction is telling about. Okay, so A9 is a number which is moved into the accumulator. Then the content of accumulator and 14H, the immediate value is added. The answer is stored in the accumulator. in this operation, in this addition operation, the carry is 0 if carry is not generated. But the operation is not just the r. It is RRC, rotate right through carry. So the meaning of RRC is rotate right through carry. So what happens is, whatever is the carry bit, so first of all, you start shifting towards right side, from left to right side, and whatever is the carry bit, that comes in the empty bit. In the leftmost part, the bit is empty when you perform the right shift operation. So the arrow shows the information about the same. What is the change between RR and RRC? You can just differentiate here on the PPT itself. So this is the change between the logic, that is the whether you want to perform the RR operation and whether you want to perform the RRC operation. Okay, so these are the 4 instructions for this shift operations, and they are very, very important when you start the programming. Okay, so no need to give the example, but so as to get the clear understanding of these instructions, I have taken one example. So after that, RLC, again the same logic. If you know the RL instruction carefully, if you understand the RL instruction carefully, the same thing. But instead of addition, what I have taken is, I have taken the set BC instruction. Means what? Say, in the previous slide, we have seen the clear instruction. So for what purpose the clear instruction is there? For clear instructions will clear the content of that register. So set instruction will set the content. So set B instruction is available for the same. When I write the set B instruction, the carry content becomes 1. Okay, so set is setting and B stands for bit. So which bit you want to set? I want to set the carry bit. So the instruction is set BC. So C becomes 1. Okay, so the set B instruction is used for setting the bit. So here I am setting the bit which is called as the carry bit, and then I have used the instruction RLC. So you have to see the format of this instruction, from which bit comes in which position, and according to that you have to shift this operation. These are very, very simple operators. So for that purpose, the 4 instructions are available in your 8051 microcontroller. So you have to remember, for shift operators, how many instructions? The 4 instruction, that is RR, RL, RLC and RRC. Now see the swap instruction. So what I told is swap instruction. So see, already I told ki what do you mean by nibble? Nibble is a combination or a group of 4 bit. So when I take a 8 bit, in that 8 bit, the 2 nibbles are there. The 2 4-bit combinations are available. So that is called as a lower nibble and higher nibble. So see, the lower nibble goes into the higher nibble and higher nibble goes into the lower nibble. So when I write the instruction move A, 72H, and when I write the instruction swap A, so after executing this instruction, the content of accumulator becomes 27A. So here in 72H, so which is the lower nibble? 2 is the lower nibble. Which is the higher nibble? 7 is the higher nibble, and they get swap. So this is the very simple instruction in this architecture of 8051 microcontroller, that is called as a swap instruction. Okay. Now see, under logical instructions, what are the different instructions we have studied? The logical operators, that is ANDing, ORing and XORing. Then shift operators, that is right shift, left shift, again with carry and without carry. Then CPL instruction, that is the complement instruction. CLR instruction, that is the clear instruction, clearing the content, and swap instruction. So these are very, very simple instructions, comes under the category called as the logical operators. Okay. Now next category is data transfer groups or data transfer instruction. These instructions are very, very important, and each and every example, each and every program, one should need this instruction called as the data transfer instruction or data transfer group. So all of you already use this instruction move. Copy the content from source to destination. So rightmost part is always source and leftmost part in this is always the destination. Now see, from controller to controller or from processor to processor, that source and destination position gets changed. So that's why I'm telling about ki in 8051 always the rightmost part is the source and leftmost part is the destination. So source contents get moved, get copied into the destination content. So what I have written here, now you should able to correlate these instructions. The move instruction is written by the number of ways, by using the number of addressing mode. Okay, so already we have used this instruction, and how you correlate ri and rn. Ri is acting as a pointer. I can be 0 or 1. And what is the n? Rn. In Rn, n can be 0 to 7, because Rn is a general purpose register, and in 8051 R0 to R7 are the general purpose registers. So you can use any one register among these. But when I write Ri, the restriction comes under there is I can be either 0 or 1, because it is at the rate symbol. So at the rate is nothing but acting as a pointer to the memory, and so as to point to the memory in RAM organization in 8051, only two registers are allocated, which are called as R0 and R1. So that's it. Now again the same instructions, same move instructions written by different ways. Now in data transfer instruction, the three basic instructions are there: move, move C, and move X. Okay. Now see, what happens is, when you want to copy the content from RAM organization, internal RAM organization, the move instruction is sufficient. When you want to move the content from code memory, that is program memory, that is ROM, you have to use the move C instruction. So we will see the program, then you will get the idea. But right now you have to just remember what is the difference between move, what is the difference between move C and move X. So just move, it is dealing with the internal RAM organization. We are dealing with the internal RAM memory. Move C means your code memory, where you write a code, where you write a program, that is your program memory. It is also called as a ROM memory. So that's why the word written as move C. C stands for code memory. Then move X. X stands for external memory. Okay, so when you are accessing the external memory, when you are copying some data from external memory to some registers, at that time one should use the instruction which is called as the move X instruction. Okay, now see, under this data transfer instruction, these three important instructions are there: move, move C, and move X. Okay, now see, what happens is, here in move C instruction, I will explain one instruction: move C a comma at the rate a plus dptr. Suppose a is a register, general purpose register. So initially a is cleared. A is cleared means 0. Dptr is a pointer register. Dptr is pointing to some memory location. So the content of that memory location gets copied into the accumulator. Okay, same program counter is pointing to some location. So program counter content, the program counter is pointing to which memory location, which code memory location, that contents are moved or copied into the accumulator. So this is the meaning of move C instruction. And same, if I am telling about the code memory, then related to that the move C instruction is applicable there. And when I am taking about the external memory, when I am introducing the external memory and user want to access the external memory, at that time how you are going to access the external memory content into the 8051 microcontroller. So for that purpose, move X instruction is available, or move X instruction is used. Okay, so three categories are there. When user is dealing with only the RAM organization, when only the internal memory, and that to be RAM memory, just use the move instruction. When you want to copy the code memory content into the registers or into the internal memory, then you should go for move C. And when you want to access the external memory, obviously you should go for the move X instruction. Okay, so these are the three instructions which comes under the category, that is the data transfer instruction. So first instruction is push and pop in the PPT. Can anyone tell me this instruction is related to what? Push
Stack.
and pop. Yes, well, already we have seen the stack pointer. So pushing the data means storing the content into the stack memory, and popping the content, pop means retrieving, getting the content from the stack memory. Now see, for time being, if you want to save any content, so you should go for the push instruction, and when you want to take the content from the stack memory, one should use the pop. So obviously, while pushing and popping the content or retrieving the content, there is a standard procedure. So obviously, when you copy the content, when you first of all copy the content to the stack memory, always it is incremented by 1. And how the track is monitored, and how you come to know where the stack, what is the exact location of stack memory, the stack pointer is available. Yes, stack pointer always point to the empty last occupied location in the stack memory. So when I want to push, when I want to store some data into the stack memory, obviously first of all I have to increment the content of stack. That is done by stack pointer, and then I can push the data into the stack memory. Now when I want to retrieve the content, so obviously I have to decrement the content of stack pointer, and then I can retrieve, I can get the content which are already stored in the stack memory. So these are very, very important instructions called as the push and pop related to the stack memory. So as to save the contents on the stack memory, and so as to retrieve the content from the stack memory. So push and pop, so directly you can, what content you want to push and what content you want to retrieve, you have to mention there. So I can write push 3, push 4 likewise. So this is related to the R3 or R4 likewise. So you can use directly the address also. Okay. Now the last instruction under this category is exchange. So are you getting the confusion between the swap and exchange instruction, or can anyone tell me the difference between swap and exchange instruction? Otherwise I will tell one example. Yes, see the format of instruction. And already I told the swap instruction in detail by the example. What is the difference between swap and exchange?
In swap, we change in between same bit,
Hmm.
and in exchange we assign a
Correct.
different value.
We assign a different value means what happens, see, when I write XCH is nothing but the exchange bit. Okay, so in the exchange bit, what happens is I write A comma RN, means the RN contents and the accumulator contents get exchanged. After executing this XCH instruction, suppose RN contents are 5 and accumulator contents are 6, they gets exchanged. Totally, the two different registers values get exchanged. But whereas in swap instruction, already we have studied, in swap instruction, only one operand is there. So in a swap instruction, always any one register is there. So according to that, register has some value, and that position gets swapped. So lower nibble and between the higher nibble. So that is the difference between this exchange instruction and swap instruction. Okay. This is very, very important instruction. So you have to study only the XCH instruction. No need to study the XCHD instruction right now. Okay. So see what we have studied in data transfer group instruction is basically what are the basic instructions under the data transfer instructions are three basic. In this way, you can remember for internal memory, only move instruction. For code memory or for program memory, or it is also called as a ROM, move C instruction. And then external memory, move X instruction. Apart from that, storing the content into the stack memory and taking or retrieving the content from the stack memory, push and pop instruction, and for exchange, XCH instruction. Yes, so these are the examples under the data transfer group. Then we will study the Boolean variable manipulation group, or sometimes in some book they have given the bitwise instruction. Okay, so why they are bitwise instruction, you will get the idea. So we'll see. Now see, how many operands you are observing for these instructions? Only one,
One.
and that to be a single bit. So that's why these are also called as the bitwise instruction. So bit addressable area already we have covered in the RAM organization. So see, what is the meaning of this instruction? It's CLRC. Means what? The carry contents are cleared. Carry is the individual bit that is available in PSW register, and that carry bit can be cleared. Cleared means when I write this instruction, whatever may be the content of carry bit earlier, now it becomes 0. Irrespective of the earlier content, when I write the CLR instruction, this carry bit becomes 0, or C is equal to 0. Okay. This is the specific instruction only for carry bit. Suppose I want to clear any individual bit from bit addressable area, or any bit in PSW register also, because PSW register is also a bit addressable register. So for that purpose, any generalized bit you can mention. For that purpose, the instruction is CLR bit. So here you can write the any one bit. So these are the two instruction. The operation is same, but CLRC is the separate instruction. It is for only carry bit, and CLR bit is for any bit in the register or in a bit addressable area. Same is the logic for set B and set B bit. So set BC means the carry bit is set. Right now in earlier case we have used this instruction. Set B means setting the bit. Which bit? Carry bit, because it is mentioned here C. Okay, and immediate after that what I have written is set B bit. So any individual bit which you want to set, that can be mentioned here. So that is called as a set B bit. Okay, so these two instructions, third and fourth instruction, is used to set the bit, whether that bit is carry bit or whether that bit is individual bit. Individual, any bit, whatever bit you want, you can mention that bit in the instruction itself. Okay, then again the next instruction is related to CPL instruction. Earlier CPL and this CPL instruction, what is the difference? A complete register content can be complemented. So when I write CPL A, so total accumulator contents get complemented. But what happens here is only carry bit gets complemented. So when carry bit earlier is 0, if I execute this instruction, it becomes 1. So if it is earlier, it is 1. After executing this instruction, then it becomes 0. Likewise, only individual bit we can set, we can clear, or we can complement. Or otherwise, we can just complement or set a complete register bits. Okay, so depending upon that, here, that's why these are called as a bitwise instruction. CPLC and CPL bit, again the same logic, used to complement the individual bit, whether that bit is carry bit or whether that bit is individual bit. Okay, again the same logic. Can anyone tell me the instructions you are observing in the PPT and earlier ANL instruction? Yes, the instructions you are observing on the PPT, already we have covered this instruction, na? So that's why I'm asking, what difference you are finding? Yes?
Here one
What is the
additional
change?
word is bit.
Means
Single
what?
bit.
Means what? No, it is not a null bit. But what is the basic change between ANL A comma R3 or ANL A comma R4? Instead of that, here I have it. Yes?
A and L C.
Hmm.
सी चेंज झालंय.
Ma'am,
What
basically,
it change?
ma'am,
Huh?
basically here we are,
C
yeah, basically here we have two operands.
Huh? In earlier case also we have two operands. We have taken two operands, na, 0f and AC likewise. But what is the change? Change is in front of you only. Yes. हाँ दर्शना कौन. हॅलो दर्शना.
मॅम ते अगोदरच्या ह्याच्यामध्ये आपण ऍड्रेसिंग मोड मेन्शन करत होते, याच्यामध्ये बिट्स
नाही
हा
तो चेंज नाही आहे. ऍड्रेसिंग मोडचा चेंज डिफरन्स नाही आहे. See the difference properly. So what is the change in this instruction is a individual bit is ANDed. Whatever is the bit can be any bit. PSW 0.0 means PSW 0th bit is ANDed with the carry bit. Are you getting? Means individual bit is ANDed. Individual bit 1 and 1 is ANDed only here. But in earlier case, complete 8-bit and 8-bit are ANDed with the with two operands likewise. Okay. So what is the changes? Individual bit. Suppose if I write, suppose I take the example that is ANL C comma bit. Bit can be any bit. So you have to mention that bit by using its address or individual position. Suppose if I mention 23H.0. So at 23H location, whatever is the 0th bit, that bit is ANDed with the carry bit. Are you getting the concept? That individual bit among that 8 bit, whether it is 0th bit, whether it is 7th bit, whether it is in between bit, that bit is ANDed with carry bit. Now, what is the difference between the second instruction? This just slash symbol is for negation again. So that bit, if that bit is 1, it is complemented to 0 and then 0 is ANDed with carry bit. Are you getting the concept? Same is the logic for ORL. Now again, right now we have studied the move instruction. So complete the 8-bit data is copied from source to destination. Here also the logic remains same. The source is bit and destination is C. So what is the bit value, individual bit value? That bit is copied into the carry bit. Now here carry bit is copied into the individual bit. So bit is user has to mention that bit here. Okay. So according to that, you can just move, you can just AND, or you can just ORL. ORL means OR operation. So these are, that's why these are called, we are dealing with, we are operating with the individual bits. The user is performing the operation on an individual bit. That's why they are called as a bitwise instruction. And that is the difference between ANL earlier case instruction and ANL C comma bit. Okay. Now again the same. JC, JNC, JB and JNB and JBC. Again I will explain one by one the name of that instruction and the what is the logic behind that. So J stands for, J is related to jump instruction. Okay. So again, so what happens is whatever is the condition of carry. So JC means if carry is equal to 1, then jump. So where to jump? This REL is nothing but user has to mention the address or any label means we can give any location, any one instruction, any one location, we can give the name. So that is also called as a label, or it has some address. So that's why jump, J stands for jump, and JC means here I am checking the condition for carry bit. If that carry bit is 1, then jump, otherwise don't jump or remain at that position. So this is the meaning of this instruction, that is called as JC. J stands for jump. Now if you understood the concept of JC instruction, so what is JNC? JNC, N is there, so N means not. So if carry bit is not equal to 1, then you jump. So according to that, these instructions are designed. J stands for jump instruction. So jump, where to jump? Whatever the address user is providing in the instruction. And whether you have to directly jump? No. Before jumping the content of the, before jumping to any location, we have to check, user has to check the condition. If that condition is true, then and then only you have to jump. So these are the instructions. Now if it is clear, JC and JNC, same is the logic for JB and JNB. Now again, the if you understand the concept, see, number of instructions are there, but don't confuse in that. In earlier case also, first of all, it is related to carry bit and it is related to the generalized bit. So here also it is related to, first two instructions are related to only the carry bit, and next two instructions are related to any generalized bit. Any bit if it is 1, and if it is not equal to 1, according to that you have to the control is to be jumped to the particular address. Okay, so these are the instructions which are called as the jump instructions. So first of all, the condition is verified, and then the control is transferred to particular address. So this is the jump instructions related to the condition, we can say. So Boolean variable manipulation instructions. So in some of the book they have mentioned as bitwise instruction. So whether the search join,
त्यांचे लेक्चर 5 वाजता आहे.
मेन्शन हे केलंय का, मेसेज टाकला?
हो, ऑफिशियल वर मेसेज
टाकलेला आहे का? ओके ओके, ठीक आहे. सी, आता हे लास्टचा जो पार्ट आहे तो परत पाहिजे तर मी नेक्स्ट लेक्चर मध्ये सांगते, कारण मला वाटतं आता हँग झाल्यासारखं झालंय. जेवढं झालंय तेवढं वाचा. Just whatever the topic covered today, just read that instructions again, and if you are finding any problem, if you have any doubt, you can ask me. Otherwise, in the next lecture again we will revise all the instructions, and I think in the next lecture the instruction set will be covered, and then we will see the port structure of 8051 microcontroller. Port structure means how you can access the input, the same pin as a input and same pin as a output for the interfacing purpose, that is used for the hardware practicals. Okay, okay, so today we will stop here. So thank you all for attending. Okay,
Thank you, ma'am.
Thank you, ma'am.